Alright, welcome to section 1.6 where we're going to work with some models and applications of some of the linear equations that we've been talking about and solving. And so this is kind of where the application comes in, where the real life comes in, to where you could, if you wanted to, write some equations to solve some problems. So modeling in math is where the real world comes to life. We will be checking out some word problems that are solved by linear equations. So for example, a new car worth $45,000 is depreciating in value by $5,000 each year. That means that when you drive that car off that lot brand new, the value of that car goes down. So we are decreasing each year by $5,000. Get my pens going here. Okay, and so we have a minus here. We're decreasing by that 5,000. And so, like for instance, if I had 2 years of owning that car, then I would do two 5,000s, multiply that by 5,000, and then I would subtract that away from the original 45,000. So what I'm thinking of for you, if you're kind of stuck on writing an equation, is to look at a specific case and kind of get some number, make up a number, and then once you have that number in there that changes, that's what you want to replace with the x, which is our variable, if that's what's changing each time. So we want to write a formula that models the car's value, y, in dollars after x years. So this expression right here models that for this situation. So the car value y is going to come from taking that original 45,000 and decreasing it by 5,000 each year. That's the one that's changing. So that's where I'm going to put my x. So again, if you need to do a specific situation, please do so. So now, can we use this formula to determine how many years, after how many years, excuse me, that the car's value will be $10,000. So the car's value was the y value. So what they're giving you here is a y value that they want you to put into that formula and solve for the number of years, which is x. So if we do that, I'm going to replace this y value with the 10,000 and rewrite the right side. And now I have a linear equation that I can solve. So what I want you to do is to, again, isolate that x term. So if I need to do that, I need to get rid of this 45,000. Now it's a positive 45,000. So to make that go to 0, let's subtract that 45,000, which gives us a negative number, but that's okay, don't panic. This gives us negative 35,000. And I want to set that equal to what's left over, because this goes away, which is negative 5,000x. Do not drop this negative in front of there. Make sure you bring it along with you. Now I have negative 5,000 times x, so if I want to get x by itself, I have to, because that is times, divide by the number next to the letter, just like what we were doing in the previous section. So when I do that, this goes away, I get x on the right side, and when I do this division, a negative divided by a negative is a positive, and then 35,000 divided by 5,000 is 7. So an easy way to do that, you can cancel these zeros out and just be left with that 35 divided by 5. So 7, now that is what? 7 years. After 7 years, that car's value will be $10,000. That's what we just found. Okay? All right. Let's try moving on to the next one. It says that we have to rent a rug cleaner. Company A will rent the machine you need for $22 plus $6 per hour. So that's a rate of change. That's something that's changing every time. So that's probably where your variable is going to go. Company B can rent the same machine for $28 but $4 per hour. After how many hours of use will the total amount spent at each company be the same? And what will that total amount be? So let's first answer that first question. But in order to do that, I need two equations for each one of my costs for Company A and Company B. So again, just like before, if you need to do a specific case, if I rent this machine for 4 hours, they're going to take 6 times 4 and add on to that 22. So the 4 I just made up, that's what's changing. So we're going to replace that with our variable. So the cost for Company B, I'm going to go ahead and write that 6 first, times however many hours that I rent it, and add on the fixed cost is what we call it sometimes, is 22. For company B, the cost that you would incur there, it's 28 plus, this is my $4 per hour. So that's what's changing. That's where I need to multiply by the x. If I rent it for 4 hours, I'm going to times it by 4 and add the 28. So replace that changing number that you make up with the x value and then add that fixed cost. So here's my two formulas that I can use for anything. If I wanted to say, okay, for company A, how much would it cost for me to rent it for 10 hours? Well, I can now use this formula, plug 10 in here, times it by 6, and add 22. Our question says, how many hours of use will the total amount be spent at each company be the same? Notice that word same, in a sense, can mean equals. So what I want to do is try to find when company A equals company B. So when is 6x plus 22 equal to 4x plus 28? And again, here is a simple equation that we can solve to find that answer. So I'm going to subtract the 4x and bring it over here on this side, get my x's on the left. I'm also going to then have to get rid of that 22 over here. So I'm going to subtract 22 at the same time just to save a little bit of space and time. This goes away and that goes away. 6x minus 4x gives me a nice 2x. Remember, that label doesn't change. 28 minus 22 gives me a 6. And just like last time, I have a number next to my letters, so I'm going to divide both sides by that number. Therefore, x equals 3. Now, x was our number of hours, right? So this is going to be after 3 hours. Each one of those values are going to be the same. Now, the last question says, what will be the total amount spent at each company? Well, if you rent it for 3 hours, what's going to be the total cost? That's when I'm going to evaluate 3 into here or to here. Doesn't matter. It's going to give me the same amount. I just have to do one of them. 6 times 3 plus a 22. And so this gives me, multiply before you add. Let's go 18 plus 22. Maybe I put C here. Therefore, the cost is going to be $40 in this situation. Okay? All right, very good, very good. Now, when we work with linear equations, sometimes perimeter and area, actually not area, but perimeter of a shape comes into play, and that's what this example is going to be. A regular swimming pool is 3 times as long as it is wide, and maybe I should say that this is a rectangle. Oh, not a regular. It does say rectangular. A rectangular swimming pool is 3 times as long as it is wide. So anytime that you have a shape that you can draw, I highly recommend that you draw that on your paper and label it. So it says that we are 3 times as long as it is wide. So if I know the width, I can go 3 times that and get my length. So for our purposes, we're going to let one of those be x, and it has to be the width. It's kind of like the second one over here. It has to be the x value. Then this tells me if I take 3 times that width, I get the length. So I'm going to represent this as 3x. Now, properties of a rectangle, hopefully remember, opposite sides are equal, and they have right angles in there. So let's move on to where we're going to get our equation. It says if the perimeter of the pool is 320, what are the dimensions? So, perimeter is important to know on a shape. If you don't recall, perimeter is the distance around a figure. So if I want to start here and travel down all the way around my rectangle, then I can add up all those sides to figure out the perimeter, the distance around that shape. So if I add up all the sides, that's going to be what's equivalent to my 320 feet. And so we are out to find the dimensions of that. So we need to know what x is. Then we can times it by 3 to get our length. I'm going to combine these like terms. 1 plus 3 plus 1 plus 3 gives me an 8x equals 320. And just like before, get rid of the number next to the letter by dividing by the number. Therefore, if I take 320 and divide by 8, 32 divided by 8 is a 4, add the 0. Therefore, my x value is 320 feet. I'm going to use that abbreviation for feet. And we haven't answered our question because that's the width. we need to now know what the length is. So I'm going to do 3 times that 40, which is going to give me 120 for the length. So technically, I'm going to rewrite it kind of all in concise form. It's a 40 by 120 foot rectangle is what we're looking for, or what solves that problem. Okay? All right, very good. Now, let's move on to our next one, which is going to give us just a little bit more of a twist to it, but it's not going to be too bad. It says that a rectangular swimming pool measures 40 feet by 60 feet. So I'm going to stop and draw that. It's 40 by 60. And it's surrounded by a path of uniform width around the 4 edges. So basically it's a sidewalk of uniform width, meaning that the distance all the way around this sidewalk is going to be the same. Okay, so this guy here is the same distance here, and this distance is the same distance here as well. Okay, now it says that the perimeter of the rectangle formed by the pool, so our outside perimeter here, that perimeter is 248 feet. We need to determine the width of the path. Now, if that's what we're looking for, we might as well just let that be x. So I'm going to let this width right here be x. Now, I did that 4 times. This is also x. And this is x, and this is x. So, I need to determine what is this length across here. Well, from here to here is 60. From here to here is x. From here to here is x. So if I put it all together, it's called a segment addition postulate in geometry. This plus this plus this should be 2x plus 60. Now, going this direction, I have a distance of 40, I have a distance of x, and I have a distance of x also. So combining each one of those makes this whole length here 2x plus 40. And so that's going to be very helpful now in order to get our equation, because they tell me the perimeter is 248. Now up here, I added all of those together, okay? But isn't it true that 2 of those is the same as x plus x, and twice of 3x gives me that 3x? Yes, it is. So a formula that you might have seen in geometry for perimeter of a rectangle was this. And I'm going to use this formula. You can definitely add up just like what we did before, but I'm going to condense it down a little bit. Twice of my length, which is 2x plus 60, plus twice of my width, which is 2x plus 40, is going to equal my perimeter, which was 248. And now I have my equation that I want to solve. So in order to do that, I must distribute these first. Distribute the 2's through. So 2 times 2x is 4x. 2 times a 60 gives me a 120. 2 times a 2x again is a 4x. And 2 times 40 gives me an 80. And I'm going to be cleaning up here on the left side. Adding a 4x and 4x gives me an 8x. 120 plus 80 gives me a 200. And now we're ready to rock and roll with solving a 2-step equation. And in order to do that, to get x by itself, don't forget we need to get rid of this 200. So let's subtract 200. And then this is gone, leaving me 8x on the left and 48 on the right. Dividing by 8, you can show that if you want, or if you're comfortable with doing that, you can just get down to x equaling 6. Now, x equaling 6, that's the width of the path. That's what we were looking at over here for x, and that is what our question asks for. Therefore, we are complete. Okay, so I know word problems scare people, but take it in pieces, draw pictures if you can, do specific examples like the first 2 to kind of get your mind thinking about how to write that equation, and hopefully that will help you out. All right? All right, now, This last part in section 1.3, so we're kind of small section here. There's many times that you need to take a formula and solve for one of the other variables. Many times in science you do this. So there's an exercise here in section 1.3 about doing that. So for example, if I have the formula for distance, rate, and time, distance equals rate times time, and I want to solve that for r, that means I need to get this r by itself. So it's kind of what we were doing in section 1.2, but now it's all going to be letters pretty much. If I have r times t, the opposite operation is to divide, and I want to get rid of that t. So I'm going to divide both sides by t. What you do to one side, you must do to the other. That cancels out, leaving me with r on this side and d over t on that side, and that is complete. Okay? Now let's try another one. Let's try this one. This is a volume for a rectangular, or not a rectangular prism, it's for a cone, actually. Or a, sorry, not a cone, a pyramid. I'm trying to think back. Alright, so this, if I want to solve this formula for b, first I have this 1/3. Always we don't like these fractions. So if I want to get rid of that 1/3 with that 3 in the bottom, we can multiply by 3 both sides to get rid of that. So I'm going to rewrite that as 3v equals bh, and this is very similar to the one previously. If I want to get b by itself, it's b times h, so let's divide by what we don't want over there, which is the h. That goes away, therefore b's final answer is 3v all over h. And again, there's multiple ways to do this. I could have divided by 1/3 here, but multiplying by the number in the bottom basically gets it gone as well. Alright, let's try this guy for m. This is like a two-step equation. If I want to get m by itself, notice I first need to get rid of this term here. Now that's a positive c that's invisible. So in order to get rid of that to the other side, we have to do the opposite of subtracting c from that side. That makes that 0. So let's go p minus c equals mc. And now I need to solve for m, which is this guy right here, multiplied by c. Let's undo the multiply by dividing both sides by something, and that something has to be what you want to get rid of away from m. Therefore, m is equal, and I'm going to flip it here, p minus c all over c. Now, I would recommend that you keep it that way, because if you end up splitting that apart into two fractions, you have to make sure that you give c to both of those. It would be p over c minus c over c, which is 1. So I would also accept p over c minus 1, but it wouldn't have to be required. Okay? Alright, and our last one for this section is, this is going to be the formula for the area of a trapezoid. If you think of it, or if you remember in geometry what a trapezoid looks like, it looks like something like that. We're going to let A and B be our parallel bases, and this guy in between is our height. So that's how you get the area of that. Again, here all we're doing is solving for B. So I have to kind of get into where B is. And there's multiple ways to do this problem, but I'm going to lead you to kind of the most simplest way. First off, notice we have this fraction. Let's just like up here, get rid of that 1/2 by multiplying by the number underneath, which is 2. Half of 2 is 1, so that goes away. And I'm left with 2a on this side equals h times a plus b. Now, your first inclination may be to go ahead and distribute that h, but I think it makes it more difficult if you do that. So I'm going to think about getting this h over here to begin with, and since that's a times, I can separate those two by dividing both sides by that letter. Okay, whatever's out there multiplied, you can divide both sides by that. So over here I'm left with 2a over h. On this side, all I'm left with is that a plus b. And now it's a sum of two things. If I want to get b by itself, I've got to get rid of that a. So that means I need to subtract a from both sides, because that's an invisible plus. That gives me a 0. And when I do that, it's going to look like this. 2a all over h. And then, whoops, not b, all over h. C equals 2a all over h minus that a value, that equals 2a all over h minus a. I wanted to subtract a b, but I was looking for b. Therefore, that is a final answer that you would have. Now, if you were to do it the other way, you would end up having, after distributing through, so another answer that would be okay would be 2a minus AH all over H would also be accepted as well. Okay? So hopefully you'll kind of get some fear away from you out of these word problems, and then these problems here, solving on for formulas, aren't too bad. They do get kind of involved, but remember to always do the opposite. What you do to one side, you must do to the other. Okay? Until next time, I'll see you for the next section.